AMD has just flipped the switch. FSR 4, its long-promised AI-powered upscaling technology, is now available in most games that support FSR 3.1 with DirectX 12. This isn't just a driver update, it's AMD's boldest move yet to rival NVIDIA's DLSS 4, promising sharper visuals, smoother frame rates, and over 85 officially supported titles right out of the gate. So what makes FSR 4 special? Unlike previous versions, it now uses machine learning algorithms to intelligently predict and fill in missing pixels during low-resolution rendering. Think of it like this: instead of brute-forcing every frame, FSR 4 analyzes patterns, motion, and detail to reconstruct a higher-resolution image. The result? Crisp visuals that look nearly native, but without hammering your GPU. This tech also pairs with frame generation, boosting FPS beyond what the hardware alone could achieve. It's AMD's answer to NVIDIA's deep learning approach, but with one major difference: FSR is open and works across multiple GPUs, not just AMD hardware. FSR 4 debuted back in March with AMD's RX 9000 series cards, but adoption was slow. That changes today. With the new Adrenalin September 1, 25 driver, gamers can now force FSR 4 in most FSR 3.1 compatible titles with just a toggle. Official support has also expanded to 85+ games, from cinematic epics like Cyberpunk 2077 to competitive racers like F1 25 and open-world adventures like Ghost of Tsushima. And for developers, this means no need to wait on special patches. Players can enable it themselves. AMD is positioning FSR 4 directly against NVIDIA's DLSS 4, which has been the gold standard for AI upscaling. NVIDIA's advantage has always been years of machine learning refinement and tensor cores built into RTX GPUs. But AMD's pitch is accessibility. FSR doesn't lock you into a specific card. You can run it on AMD GPUs, some NVIDIA cards, and even on consoles that integrate AMD hardware. That wider ecosystem could be the key to getting millions of gamers on board. So what does this mean for gamers? Expect higher frame rates without a noticeable loss of visual quality, especially at 1440p and 4K. For competitive titles, frame generation could push performance into triple digits even on mid-range cards. And while some purists will always prefer true native rendering, the trade-off is undeniable. More frames, less GPU strain, and visuals that look good enough for both casual and hardcore players. With FSR 4 finally rolling out broadly, the next question is, where does AMD go from here? Developers are expected to bake it directly into upcoming releases, while AMD will likely fine-tune the ML models to improve artifact handling and motion clarity. If adoption continues at this pace, we could be looking at a real shift in the upscaling wars, where AMD isn't just catching up to NVIDIA, but setting the standard for cross-platform game optimization. So there you have it. FSR 4 is here, it's AI-powered, and it's ready for most of your favorite games. Will it finally close the gap with NVIDIA's DLSS, or even overtake it thanks to its open approach? Let us know your take in the comments. Are you switching on FSR 4 right away, or sticking with native rendering? And if you found this breakdown helpful, don't forget to like, subscribe, and stay tuned for more gaming tech deep dives.